Hi Logic fans, what's up? Welcome to another video, 6.5, our fifth section on quantificational syntax. Here we introduce the new rule Existential Instantiation. Let's rock. Okay, so by now we're accustomed to being introduced to these new rules, and so let's just jump straight into this one, Existential Instantiation EI, which allows us to detach an existential quantifier from a sentence. So you're going from there exists something, for example, there exists an x such that x is f to fv or something along these lines. All right. So let gamma be any individual variable. So x, y, z, and alpha be any existential pseudoname, not a universal pseudonym, not an individual constant like a, b, or c. Okay. Then given an existentially quantified sentence, for example, there exists an x such that fx, you can detach this and infer the sentence, alpha, provided alpha doesn't occur in any previous line, not just this line, but any previous line going back up, okay? So alpha is going to be like a v replacing the alpha, and you have to replacing the gamma, and you have to replace every occurrence of it, right? So if it was fa and ga, then you would have to write fv and gv. And you can't make any other changes, okay? So we're going to go through some of these exercises and explain all the parts of the rule, and then we're going to look at some examples so that you really understand the intuitive rationale behind the rule and why it's formulated the way it is. So in each of these cases, just as in the previous videos, you've got a premise and a conclusion that is drawn from that premise by application of EI. And the question is whether or not that application of EI is permissible or impermissible. So go ahead and give all of these a shot, and we'll run through them together to make sure we're clear on all the aspects of this new rule, existential instantiation. And I should mention, just like all of the other previous new rules we've introduced, EI, EG, UI, UG, it is a rule of inference and not replacement. So pause now and give this a shot. Okay, hopefully you've had a chance to work these through and get them, and let's just start with A here and roll right through. Here you've got an existentially quantified sentence. Can you go from that to FA? And the answer is no, this is impermissible. Alpha has to be an existential pseudonym, it has to be V. Now, why can't you do this? It looks intuitive enough. Well, let's just think about this for a second. Here you know that at least one thing is F. Does it follow that you know that the particular thing A has the property F? No, right? So just because there's at least one thing in Santa's bag that's a good present, it doesn't follow that the particular thing A in Santa's bag is a good present, right? So this is impermissible, and alpha has to be an existential pseudonym. You cannot go from an existential to a particular constant, right? Remember, existential and universal quantifiers introduce ways of speaking generally without referring to a particular thing. Right, so this speaks generally and doesn't refer to any particular thing, and therefore you're not allowed as a matter of unaided logic to conclude something about a particular thing. Okay, B. Is B permissible? No, B is impermissible. You cannot do this, and the proviso that's violated here is B. You have to replace every occurrence of gamma with alpha. In this case, gamma is y, and it occurs in two places, and you're detaching the quantifier in terms of y. So it would have to replace both of them, and you also cannot make any other changes. Okay, so the correct way to do it, by contrast, is what you have in C. So comparing B and C is really useful. B is impermissible, do not do it. C is permissible and A-OK. And the only way to really apply existential instantiation, given what we have here. All right, let's look at D. And D is permissible. This is absolutely allowed. You can do this. You're replacing the Y. You're detaching this in terms of Y, and you leave everything else alone. That is absolutely okay and a way to go. I should mention that, remember, now that we've introduced these pseudonyms, universal and existential, you cannot end a syntactic deduction with a line that has a pseudonym in it, either universal or existential. There cannot be a pseudonym in the last line of any deduction. So we would have to go on and maybe existentially generalize this to do a complete thing. But in terms of the move from this to this via existential instantiation, that is perfectly permissible. This is absolutely impermissible. Do not do it. Once again, alpha has to be an existential pseudonym. Here it is a universal pseudonym, and you cannot go from at least one thing has the property F to therefore the arbitrary, sufficiently general thing U has the property F. Absolutely not allowed. Okay, F, let's take a look at what we have here. This is impermissible because you cannot replace different kinds of variables here. Here you have an individual constant and an individual variable. You can only replace the variable, so that is impermissible. Do not do that. See, you're replacing the individual variable, right? Where gamma is an individual variable, all right? Okay. Let's take a look at G. And G is impermissible. Do not do this. It is not allowed. You have to replace every occurrence of gamma with alpha. And if you look back to chapter 4, where we discussed quantifiers and what are sentences and what aren't, we noted that this was what's called an open, unbounded, or free variable. This isn't even a sentence here, okay? We have no, this is an unbounded individual variable, and so this is absolutely impermissible. You have to replace both. You have to replace every occurrence, okay? Here's a very interesting case. H is impermissible. Do not do it. But I want to be very careful about where exactly it goes astray, all right? So you have two premises here, and then the person does EI twice. So this is absolutely fine. You can apply EI from 1 to 3, right? You also could have gone from 2 and then 3 GV. That would have been okay as well. What you absolutely cannot do is do V and then GV, and the problem that this violates here is A, alpha does not occur in any previous line. So alpha, recall, is going to be the existential pseudonym. So we use V here, but look at this. V occurs in a previous line. So you cannot do that. And I have a problem that we're going to discuss later that explains why you cannot do this. But just for now, the rule, that's what the rule is saying. The rule is saying you cannot do that. You would have to go to a different existential pseudonym, so a V sub 1, V sub 2. That would be okay. But since the V occurs in a previous line, namely this one, you cannot do that. And that's a violation of proviso A here. All right, let's take a look at I. This is impermissible, and it's impermissible because existential instantiation is a rule of inference and not replacement. This is a disjunction. You cannot go inside the disjunction and start screwing around, right? Existential instantiation can only apply to an existentially quantified sentence, rule of inference, right? So this is okay, this is permissible, and again, you can't end a syntactic deduction with an individual, with a pseudonym, existential or universal, so you'd have to go on and close that off. But as far as the EI inference from 1 to C here is concerned, that is a perfectly legitimate use of EI. And again, contrast I with J. This is a disjunction. This is an existentially quantified sentence. Permissible, impermissible. Don't do it. All right, excellent. Let's take a look at some actual problems now that we kind of understand all the features, all the formal features of the rule existential instantiation. All right, as is my wont, I want to start us off with a relatively simple example just so you can get a feel for it. And here you have this is conclusion C. Here you have a premise. Something is both red and round. Therefore, at least one thing is red, and intuitively that is valid, and it absolutely is. Your task is to prove it. So let's go ahead and do that. I'll give you a little bit of a hint, right? So what I've done here is I've taken the pardon me, what I want to do here is I want to look at the conclusion, and then I want to just sort of reverse engineer it, right? Let's just look at what the conclusion that we're trying to get to from the premise looks like, devoid of any quantifiers, and it would look like FV or something. So what I'm trying to do is I'm trying to build to FV so that I can existentially generalize to the desired conclusion. So pause now and give that a shot. Okay, so hopefully you were able to figure this one out, and recall, we have to start combining all of our different rules together, but from the premise, we existentially instantiate it, which is the rule of the day, and we have to go to this. We can't leave this with like a Y, and we can't have like a V and an A. We can't have any A's or B's or C's. It's got to be all V's, right? And then looking at what we're trying to get to, we need the F by itself, which is what this sort of showed us. So we simply simp it out, and then we existentially generalize on it. And we could have existentially generalized to Y or to Z or anything we wanted there in terms of an individual variable, but since this particular problem's conclusion is in terms of X, we generalized in terms of X. All right. Okay, so for this particular problem, I want to highlight why existential instantiation carries one of the provisos that it carries. So here's an alleged syntactic deduction. It is not an actual one because it violates one of the parameters of existential instantiation. And I want to know if you can figure out which one. Okay, so your first clue that something goes wrong with the syntactic deduction is that the argument 1, 2, therefore what we have in 6 here, okay, is in fact invalid, right? And let's just think about this for a second. If we have a domain with A and B, and A has the property F but lacks G, and B is the opposite, it lacks F but has G, then there's at least one thing that's F, there's at least one thing that's G. Those are both true, right? But is there at least one thing that's both F and G? No, right? So the conclusion's false. So from a semantic point of view, this is an invalid argument, and therefore it should not be syntactically deducible, yet this looks like a syntactic deduction. Where does it go wrong? Pause now and see if you can't figure it out. Okay, hopefully you've had a chance to puzzle this one out, but it goes wrong right here, okay? And the problem is that the proviso it violates is, remember, there's this proviso on existential instantiation that says the pseudoname you existentially instantiate to cannot occur in any previous line, and here it does occur in a previous line, okay? And that's what allows the mistake. So let's just think about this intuitively for a second. Suppose this says there's at least one thing that's red, and suppose this says there's at least one thing that's blue. This says there's at least one thing that's both red and blue, right? Which of course is ridiculous. And the problem is that, when you went to FV, or this V stands for some unknown one thing in there, and then you used the same one, right? So the correct way to have done this would have gone to V1, and then you would go to V1 here, and then you would get there exists an X such that XV1 there, right? And then, of course, you would still have to finish it off with another one, but maybe you would finish it off by doing, let's do it this way. Maybe we would existentially generalize that one to include a slightly different statement, like, let's see here. Let's do it this way. Y, right? And this would be okay. This would be existential generalization on 6, and that's absolutely okay. There's at least one Y and there's at least one X. That does indeed follow from these premises, and that's okay, right? With the V1 that forces you to set up a separate thing. Maybe V is identical with V1, maybe not, and that's what's getting caught here, okay? So that's the reason for the proviso that says the existential pseudoname that you instantiate to cannot have occurred on a previous line, because you would then thereby perhaps mistakenly be assuming that it's the same thing in the domain when it need not be. Okay, let's flip over to the next video and practice a couple more problems.